So we've gotten pretty good at teaching AI to find answers in our documents, using that technique called RAG. But what if just finding answers isn't really the goal anymore? What if we want it to investigate? That's what we're diving into today. This idea of agentic file exploration, where AI stops being a search engine and starts acting more like a detective.
Okay, let me ask you something. What if your AI could do more than just, scan for keywords? Imagine it could read your entire library of files, and I mean really read them. See all the connections, the little threads linking one document to another, and then actually follow that trail of evidence, just like a detective on a case. That's the huge promise we're looking at here.
But, hey, before we get to the cool new stuff, we've got to understand what most systems are using right now. And, more importantly, why it's kind of broken. So, first up, the limits of RAG.
All right, so RAG. It stands for Retrieval Augmented Generation. The idea is pretty simple, actually. When you ask the AI a question, it doesn't just pull an answer out of thin air. First, it does a quick search. It retrieves little bits and pieces of info from your documents. Then it uses those facts to generate a way more accurate, context-aware answer. Makes sense, right?
So the big question is, how does it find those perfect little snippets? Well, it uses something called semantic similarity. Basically, it chops up all your documents into these tiny little chunks, and then it just finds the chunks that sound the most like your question. It's super fast, and yeah, it seems really clever, but, and this is a huge but, this exact process is what creates a massive, massive blind spot.
And that blind spot? It's called chunking. Honestly, it's the fatal flaw of the whole approach. Think about it. When you shred your documents into these tiny, isolated pieces, you completely lose the big picture. The AI has no idea how paragraph 5 connects back to the intro, and there's no way it can follow a little note that says, hey, for more on this, check out this other file. So, if the answer you're looking for is spread out, well, standard RAG is pretty much guaranteed to fail.
Okay, so if chunking is the villain here, what's the hero of the story? This is where we get to a totally new way of thinking, an approach that acts less like a simple search engine and, well, a lot more like that detective we were talking about. This is exploration.
And this quote from the person who built this project, it just hits the nail on the head. They're basically saying, let's stop trying to make machines match words and start making them think like humans do when they're looking for information. The whole goal is to copy how you or I would actually research something, following leads, connecting the dots. It's a huge shift from just passively retrieving stuff to actively exploring it.
And this comparison really lays it all out. The old way, retrieval, is all about finding similar chunks. It's static. The new way, exploration, is about following a trail of evidence. It's dynamic. See the difference? We're moving from just matching keywords to conducting a full-on, context-aware investigation. It doesn't ignore those cross-references. It follows them. That's the game changer.
So how does this actually work under the hood? Well, it all comes down to a really smart 3-step process for navigating through all those files.
First, it does a high-level scan. It just kind of glances at all the documents to get a lay of the land, figuring out which ones might be important. Then it goes into a deep dive. It picks a promising file and reads the whole thing, top to bottom. But, and this is the magic part, while it's reading, it might see a little note mentioning another document it didn't think was important at first. That's when it hits the third phase, synthesize. It uses this incredible ability called backtracking, where it can literally pause, go back and read that new file it just discovered, and then pull everything it's learned together into one complete answer. It can actually change its mind and follow a new lead, just like we would.
So the big takeaway here is that this is not a straight path from A to B. The agent is dynamic. It can follow a new hunch, go down a totally different rabbit hole, and even circle back to something it skipped earlier. It's not just grabbing pre-cut puzzle pieces, it's actively drawing the map as it explores the territory.
All right, let's peek under the hood a bit. What kind of tools and tech does an agent like this need to pull off such a complex job? Basically, the agent has 6 main tools in its belt. It can scan folders to see what's there, parse documents to get them into a standard format, preview a file, or just read the whole thing. It can also do a regex search for specific patterns or find a file by its path. You can think of these as its basic skills for getting around any digital library.
Okay, but having the tools is one thing. Actually using them in the right order for a complex, multi-step investigation, that's a whole other level of difficulty. You need an AI model that can genuinely reason and plan ahead, like a chess master.
And that, as you can imagine, takes some serious computational horsepower. Your average, smaller model, it would just get lost.
So how much horsepower are we talking? Get this. The minimum to make this work reliably was a model with 32 billion parameters. 32 billion. And even with a model that huge, you still have to give it really precise instructions so it actually uses its tools to find real evidence instead of, just making stuff up. The whole tech stack behind this is really cool. You've got Llama Index acting as the quarterback, or the agent's brain, calling the plays. Then there's this handy tool called Dockling that works like a universal translator, turning every file type into clean markdown that the AI can understand. And of course, all of this needs to run on some beefy hardware with a ton of memory. You absolutely need it to handle these giant models.
Okay, that's the theory, that's the tech. But so what? What does this actually let you do in the real world? Let's look at the kind of question this system can tackle that would leave a normal RAG system completely stumped.
Imagine asking this question about a company merger. What were the key risks, and how did we plan to fix them? The answer isn't going to be in one neat little paragraph. No way. You'd have to look at the risk assessment report, then find the board meeting minutes where they discussed it, and then maybe a separate legal doc with the final plan. The answer is scattered all over the place.
So, to answer that single question, how many steps do you think the agent had to take? It took 14. 14 separate steps. That includes scanning folders, reading files, finding a new lead in one document, backtracking to go read a different document, and finally stitching it all together.
And that right there is why this is so powerful. We need to be clear. This isn't about getting an instant answer from a chatbot. Think of this more as a document generation engine. It's not fast. It might take several minutes because it's conducting a real investigation. But at the end, it doesn't give you a sentence. It gives you a full, detailed report that pulls together everything it discovered. So this all leaves us with a pretty profound final thought. We're moving away from AI that just finds little snippets of text to an AI that can actually understand context and create new knowledge. So, if an AI can really understand the entire web of connections in all of a company's files or across an entire library of scientific research, what kinds of questions, the ones we thought were impossible to answer, are we finally going to be able to ask?